Good evening, students. Today we are going to discuss the topic method of solving first order, first degree differential equation. That is, here the differential equation is of the form dy by dx equal to f of xy. That is, the first order, first degree differential equation can be written as dy by dx equal to f of xy. That is the function of x and y. Dy by dx equal to the function of x and y. Here dy equal to f of xy into dx. In this case, we can see dy by dx as the form, the function of x into function of y. That is, dy by dx equal to a function of x into a function of y. That means, let us consider the differential equation dy by dx equal to 1 plus x square into 1 plus y square. That is, here dy by dx is a function of x into function of y. Next, we can considering dy by dx equal to xy plus x plus y plus 1. Now here it is equal to, how can we change into function of x into function of y? First term xy plus x, here xy plus x can be, make it as group. Here x is the common factor, therefore x into y plus 1 plus 1 into y plus 1. That implies here y plus 1 is the common factor, therefore we can take y plus 1 into x plus 1. That is, it is of the form what? F of xy, that is function of y into function of x or function of x into function of y. Therefore, in here we have to consider this type of differential equation. How can we solve first order, first degree differential equation? By using variable separable method. That is, the function dy by dx equal to f of xy. Here the function of x and function of y. By using variable separable method, we have to separating the variable. Let us consider the question dy by dx equal to what? xy plus x plus y plus 1. That implies x into y plus 1 plus 1 into y plus 1. That is equal to x plus 1 into y plus 1. That is here the function of x into function of y. Next, we have to considering the variable separable method. In this method, we have to separate the variables. That is, first we have to arrange dy by y plus 1 equal to x plus 1 into dx. That is, here the function of y dy equal to function of x dx. It is of the form n dy equal to m dx. First we have to separating the variable. Therefore, here the first order, first degree differential equation can be expressed as the form n dy equal to m dx. Here n is the function of y and the m is the function of x. Next, we have to integrate this differential equation. We will get the general solution. We have to integrate on both sides. Integrate on both sides. Therefore, integral n dy equal to integral m dx. When we integrate this differential equation, we will get a general solution. In this general solution, we have to apply the value of x and y. We will get the corresponding arbitrary constant. That means we will get a particular solution as the point of x and y. Next, consider the question. Solve dy by dx equal to x raised to 5 plus x square minus 2 by x. Here, first we have to arranging the function is of the form n dy equal to m dx. That is, here dy equal to what? X raised to 5 plus x square minus 2 by x dx. This is of the form n dy equal to m dx. Next, we have to integrate on both sides. Integrate on both sides. Integral dy equal to what? Integral x raised to 5 plus x square minus 2 by x dx. Next, integral dy is equal to y. Y equal to integral x raised to 5 plus x square minus 2 by x dx. That is integral x raised to 5. That is x raised to 6 by 6 plus integral x square. That is x cube by 3 minus 2 into integral 1 by x. Integral 1 by x is log x. Log mod x plus c. This is the general solution of the differential equation by using variable separable form. If we apply the value of x and y, we will get the value of the constant c. Therefore, we will get a particular solution as the value of x and y. Next question. Consider the differential equation x square dy by dx minus 2xy equal to 0. Write the equation of the form f of y dy equal to g of x dx. Then second question, solve the given differential equation. That is, first we have to write the variable separable form. Next, we have to find out the general solution of this differential equation. Here, the given differential equation is x square dy by dx minus 2xy equal to 0. That implies x into dy by dx minus 2y equal to 0 throughout dividing by x. That implies x into dy by dx equal to 2y. It is equal to what? Dy divided by y equal to 2 divided by x into dx. We have to arranging this differential equation in the form f of y dy equal to g of x dx or n dy equal to m dx. Next, we have to integrate on both sides. This is of the form what? Dy by d equal to 2 by x dx. That is f of dy equal to g of x dx. That is the first question solved. Second one, solve the given differential equation. Next, we have to integrate on both sides. Integrate on both sides. We will get integral dy by y equal to integral 2 by x dx. Integral 1 by y dy, that is integral of 1 by y is equal to log y. Therefore, log y equal to 2 into integral 1 by x dx, that is 2 into log x. That implies integral dy by y equal to integral 2 by x dx. It is equal to what? Log y. That is integral 1 by y dy means log y equal to 2 into integral 1 by x dx, that is log x plus the constant c. Here we can use an arbitrary constant log c. That means it is a constant value. Therefore, we have to consider c as log c. That implies log y equal to what? Log of x square. That is 2 log x equal to log x square by n log m equal to log m raised to n. Therefore, here 2 log x equal to log x square plus log c. That implies log y equal to log a plus log b. That is log ab. Log a plus log b is equal to log ab. Therefore, log c into x square. That implies y equal to what? Cx square. This is the general solution of the differential equation x square dy by dx minus 2xy equal to 0. Next question. Find the solution of the differential equation dy by dx equal to 1 minus cos x divided by 1 plus cos x. First, we have to consider 1 minus cos theta and 1 plus cos theta. We know that cos 2 theta equal to 1 minus 2 sin square theta. And again, cos 2 theta can be written as 2 cos square theta minus 1. Now here, instead of 2 theta, in this question it is cos x. Therefore, how can considering cos x equal to what? 1 minus 2 sin square x by 2. Because here cos 2 theta can be expressed in terms of theta. Now that is cos x can be written as in terms of x by 2, half of this theta. That implies cos x equal to 1 minus 2 sin square x by 2. Therefore, 2 sin square x by 2 equal to what? 1 minus cos x. This will be taken as this side and minus 2 sin square x by 2 taken as this side. Arranging. Therefore, 2 sin square x by 2 equal to 1 minus cos x. Next, we know that cos 2 theta equal to what? Again, it can be expressed in terms of cos theta. That is 2 cos square theta minus 1. Take it as this one. Therefore, cos 2 theta equal to 2 cos square theta minus 1. Here, cos x equal to what? 2 cos square x by 2 minus 1. Next, minus 1 taken as this side. Therefore, 1 plus cos x equal to what? 2 cos square x by 2. First, we have to change 1 minus cos x as 2 sin square x by 2 and 1 plus cos x as 2 cos square x by 2. Then substituting the values here. Therefore, dy by dx equal to, first one, 1 minus cos x is 2 sin square x by 2 by 1 plus cos x is 2 cos square x by 2. 2 cancelled. Then sin square x by 2 by cos square x by 2. That is tan square x by 2. Sin theta by cos theta. That is tan theta. Therefore, sin square x by 2 divided by cos square x by 2 is tan square x by 2. Therefore, the given differential equation can be changed in the form dy by dx equal to what? Tan square x by 2. Next, we have to use the variable separable method. We have to arranging the function in the form of n dy equal to m dx. That is dy equal to tan square x by 2 dx. We know that sec square theta minus tan square theta equal to 1. Therefore, tan square theta equal to what? Sec square theta minus 1. Then here tan square x by 2 can be written as sec square x by 2 minus 1. Therefore, dy equal to sec square x by 2 minus 1 dx. Next, integrate on both sides. We will get the general solution. Therefore, integrate on both sides. Therefore, integral dy equal to what? Integral sec square x by 2 minus 1 dx. Therefore, integral dy, that is y equal to what? Integral sec square x by 2 minus 1. Integral of sec square x by 2 what? Tan x by 2. That is tan x by 2 by 1 by 2. That is derivative of x by 2. That is 1 by 2. How can we find out the integral of sec square x by 2? First, we have to consider integral of sec square theta. That is tan theta divided by the derivative. Here, the derivative of x by 2. That is 1 by 2. Minus integral of 1 dx. It is x plus c. That is y equal to what? 2 tan x by 2, 1 by 2. Then take as reciprocal. That is 2 tan x by 2 minus x plus c. Y equal to 2 tan x by 2 minus x plus c. This is the solution of the differential equation dy by dx equal to 1 minus cos x divided by 1 plus cos x. Answer the question. Solve sec square tan by dx plus sec square y tan x dy equal to 0. First, we have to arranging the differential equation in the form n dy equal to m dx. That is, first we have to arranging as a variable separable form. Therefore, here sec square y tan x dy equal to minus sec square x tan y dx. It is equal to what? Sec square y. Now here tan y. Therefore, tan y take it as this side. Therefore, sec square y divided by tan y dy. First, we have to arranging n dy form equal to. Next, we can considering minus sec square x divided by tan x dx. Next, integrate on both sides. Integral sec square y by tan y dy equal to minus integral sec square x by tan x dx. Now here d by dx of tan x is sec square x. Then dy of tan y is sec square y. That is, here the function is of the form what? F dash of x by f of x dx. Therefore, the value will be log of f of x. The integral value. We know that integral f dash of x by f of x. What is the value? Log of f of x plus c. Same manner here, derivative of tan y is sec square y. Therefore, it is of the form f dash of y divided by f of y dy. That is equal to log of tan y equal to, now here what? Same manner, f dash of x by f of x. That is, here f of x is tan x. Then derivative of tan x is sec square x. Therefore, it is equal to minus log of tan x plus constant. We can take it as log k. That implies log of tan y then plus log of tan x equal to log k. That implies log of tan y plus log of tan x. That is log a plus log b. That is log ab. Now here log of tan y into tan x equal to log k. That implies log of mod tan y tan x. That is, the value will be plus or minus. K will be plus or minus. Okay. Now here the value will be tan y tan x equal to mod tan y tan x equal to k mod tan y tan x equal to what? K. That means tan y tan x equal to plus or minus k equal to k. That implies tan y tan x equal to plus or minus k. We can replace this plus or minus k as another arbitrary constant c. That is tan y tan x equal to c. It is the general solution. That implies tan y tan x equal to some constant c, where c is equal to what? Plus or minus k. Therefore, this is the general solution. Next question. Solve dy by dx equal to 1 plus x square into 1 plus y square. Here, first we have to separating the variables. Therefore, dy by dx divided by 1 plus y square equal to 1 plus x square into dx. Next, integrate on both sides. Therefore, integrate on both sides. Integral dy by 1 plus y square equal to integral 1 plus x square dx. Integral 1 by 1 plus y square dy. We know that integral 1 by 1 plus x square dx equal to tan inverse of x. The same manner here, integral 1 by 1 plus y square dy, that is tan inverse of y equal to integral 1 plus x square, that is integral of 1 dx. Integral 1 dx is x plus integral x square dx is x cube by 3 plus c. This is the required general solution. Next, answer the question. Find the general solution of the differential equation e raised to x plus e raised to minus x dy minus e raised to x minus e raised to minus x dx equal to 0. E raised to x plus e raised to minus x dy minus e raised to x minus e raised to minus x dx equal to 0. First, we have to separate the variables. Therefore, e raised to x plus e raised to minus x dy equal to e raised to x minus e raised to minus x dx. Next, dy equal to, we have to arranging the function is of the form n dy equal to m dx. Therefore, here dy equal to what? E raised to x minus e raised to minus x divided by e raised to x plus e raised to minus x into dx. Next, integrate on both sides. Therefore, integral dy equal to integral e raised to x minus e raised to minus x divided by e raised to x plus e raised to minus x dx. Now here, integral dy, that is y equal to integral e raised to x minus e raised to minus x divided by e raised to x plus e raised to minus x. Here, it is of the form f dash of x by f of x. That is e raised to x plus e raised to minus x is f of x. Then the derivative of e raised to x plus e raised to minus x is what? E raised to x minus e raised to minus x. Let us considering f of x is e raised to x plus e raised to minus x. Then f dash of x what? E raised to x plus e raised to minus x into minus 1. That is equal to e raised to x minus e raised to minus x. Therefore, this integral is of the form f dash of x by f of x dx. Therefore, this integral is what? Log of f of x. That implies y equal to what? Log of mod e raised to x plus e raised to minus x plus c. This is the general solution of the given differential equation. Next question. Consider the differential equation dy by dx equal to e raised to x minus y plus x square e raised to minus y. First, express this equation of the form f of y dy equal to g of x dx. Then next, we have to solve this differential equation. Therefore, first, given dy by dx equal to e raised to x minus y plus x square e raised to minus y. It implies e raised to x minus y means e raised to x into e raised to minus y. That is, e raised to x minus y can be written as e raised to x into e raised to minus y. That is e raised to m plus n equal to e raised to m into e raised to n. Same manner here, e raised to x minus y equal to e raised to x into e raised to minus y equal to e raised to x divided by e raised to y. Therefore, e raised to x minus y can be written as e raised to x by e raised to y plus x square by e raised to minus y. It can be written as 1 by e raised to y. That is x square by e raised to y. That is equal to e raised to x plus x square divided by e raised to y. That is dy by dx equal to what? E raised to x plus x square divided by e raised to y. Next, we have to separating the variables. That is e raised to y dy. E raised to y dy equal to e raised to x plus x square into dx. Integrate on both sides. That is integral e raised to y dy equal to what? Integral e raised to x plus x square into dx. That is equal to what? Integral e raised to y. That is e raised to y equal to integral e raised to x plus x square dx. That is e raised to x plus integral x square is x cube by 3 plus c. That is e raised to y equal to e raised to x plus x cube by 3 plus c. Next, consider the differential equation dy by dx equal to 2a by y. In this question, first write the given equation in variable separable form. Second one, integrate the variable separable form. That means we have to find out the general solution. Next, third condition, get the value of the arbitrary constant using y of 0 equal to 2. That means here we have to find out the particular solution. That is when x equal to 0, the y value is 2. Therefore, substituting this given condition in our general solution, we have to find out the particular solution. That means here we have to find out the particular arbitrary constant value. After that, applying that constant in this general solution, we will get the required solution. Okay. Now, first, dy by dx equal to 2a by y. Therefore, y into dy equal to 2a into dx. Y into dy equal to 2a into dx. Therefore, integrate on both sides. Therefore, integral y dy equal to integral 2a dx. That implies, first we have to write the variable separable form y dy equal to 2a dx. Next, we have to integrate this variable separable form. Therefore, integral y dy equal to integral 2a dx. That is integral y dy, that is y square by 2 equal to integral 2a dx. That is 2a into x plus c, an arbitrary constant. This is the general solution of the given equation. Next, third condition. What is third condition? Get the value of the arbitrary constant. Here we have to find out the value of constant c when x equal to 0, the y value is 2. That means here put when x equal to 0, y is equal to 2. Therefore, substituting y is equal to 2, that is 2 square by 2 equal to what? 2a into 0 plus c. X value 0, then the y value will be 2. When x equal to 0, y is equal to 2. That is the given condition. That is y of 0 equal to 2. That implies, what is the value? C is equal to what? 2 to cancel. Therefore, C is equal to what? 2. Next, we have to substituting the value of C in the general solution. That is, write the solution of the differential equation. The fourth question is write the solution of the differential equation. How can I find out the solution? Next, we have to apply an arbitrary constant can be changing to a particular constant. That is, here we have to substituting the value of C, that is y square by 2 equal to 2ax plus 2. That implies y square equal to 2 into 2ax, that is 4ax plus 2 into 2, that is 4. Y square equal to 4ax plus 4. This is the solution of the differential equation. Next question, find the particular solution of the differential equation dy by dx equal to y tan x when x equal to 0, y equal to 1. First, we have to write this given differential equation in variable separable form. That is dy by dx equal to y tan x. Therefore, dy by y equal to tan x dx. Next, integrate on both sides. That is integral dy by y equal to integral tan x dx. That is equal to integral 1 by y dy. That is integral 1 by y dy equal to log y. That is log y equal to integral tan x dx. That is log sec x. Integral of tan x is log sec x. That is log mod sec x plus arbitrary constant c. That implies, now here we can considering c as log c. That is, it is again an arbitrary, log c is an arbitrary constant. Therefore, instead of c, we can considering log c. That implies log sec x plus log c. That is log a plus log b. That is log ab. That is log of c sec x. That is log y equal to log of c sec x. Therefore, y equal to c sec x. Next, the given condition, when x equal to 0, the y value is 1. By substituting this value, we will get an arbitrary constant c. When x equal to 0, y equal to 1. When x equal to 0, y equal to 1 implies 1 equal to c sec 0. The value of sec 0 is 1. That implies c equal to 1. Since sec 0 equal to 1. C equal to 1. When c equal to 1, what is the solution? Y equal to sec x. Therefore, the solution is y equal to sec x. Here, the condition when x equal to 0, y value 1. Therefore, substituting this condition here, we will get c equal to 1. Then, substituting the value in this general solution, y equal to sec x is the required solution. Next question, find the particular solution satisfying the given condition. Cos of dy by dx equal to a, where a belongs to real number, y equal to 1 when x equal to 0. Find the particular solution. Here, given cos of dy by dx equal to a. Therefore, dy by dx equal to what? Cos inverse of a. Cos of dy by dx equal to a. Therefore, dy by dx equal to cos inverse of a. Next, dy equal to cos inverse of a dx. Integrate on both sides. Therefore, integral dy equal to integral cos inverse of a dx. That is equal to integral dy equal to y. Then integral cos inverse of a dx. That is cos inverse of a is a constant. Therefore, cos inverse of a into integral dx, x plus c. Next, we have to substituting the value when x equal to 0, y equal to 1. Substituting when x equal to 0, the y value is 1. Substituting here, we will get an arbitrary constant c. That is when x equal to 0, y equal to 1. Therefore, 1 equal to cos inverse of a into 0 plus c. That implies c equal to 1. Cos inverse of a into 0. That is the term will be 0 plus c. Therefore, c equal to 1. Next, substituting the value in y equal to cos inverse of a x plus c. That is, therefore, y equal to what? Cos inverse of a x plus 1. That implies cos inverse of a x equal to what? Y minus 1. Y minus 1. That implies cos inverse of a equal to what? Y minus 1 by x. Cos inverse of a equal to y minus 1 by x. Therefore, a equal to what? Here we get cos inverse of a equal to y minus 1 by x. Therefore, a equal to cos of y minus 1 by x. This is the required particular solution.